Okay, we just saw this alternative to minimizing the mean square error, which is minimizing the mean absolute value of error, right? Instead of a square, we just put an absolute value sign. This, like we said, is also called L1 regression because there's something called an L1 norm, um, and the L1 norm of the error vector, E1, E2, E3, is just summation 1 to n EI, right? This is basically the L1 norm divided by n, where this is the L1 norm, okay? So we'll see what a norm is in a minute. Anyway, so this is called the least absolute residuals method because these errors are also called residuals. Residuals meaning the difference between the model and the data. What is what remains after subtracting the data from the model is called the residual, and we are doing the least absolute residuals. So it's called the LAR model or the least absolute residuals model or regression or L1 regression. It's called various things. If you want to use MATLAB, um, the function called fit allows you to do this kind of regression. Um, I'll show you my own version of L1 regression that I provide a program for that you can use as well in a MATLAB demo. Okay, so this is called the L1 norm. It turns out the least squares method, the usual minimizing the mean square error method, is sometimes called the L2 regression as opposed to the L1 regression. And it's called L2 regression is because what's called the L2 norm is square root of summation over 1 to n EI squared. Right? So this is actually called L2 norm, which is the usual distance, right? So this is the magnitude of this vector. The magnitude of vector classically defined is called the L2 norm. Okay, like I said, I'll talk about norms in a minute separately. Um, Norm is just a mathematical concept that generalizes the notion of length and distance, right? So this is the classical magnitude of vector or length of a vector, and this is sort of a different way of measuring the length of a vector, right? And you want to minimize that as much as possible. And this is called the L2 norm because there's a square. This is called the L1 norm because there is no square. There's just power 1, okay? Very quickly, why does L1 norm based regression avoid being affected by outliers? Um, it's because, well, L2 norm is affected by outliers because when the error is large, when you have an outlier which is far away from most of the data, um, if you draw a line through most of the data, then this outlier will have a huge error. So to reduce that error, this best fit line will go toward that outlier. Now, because we are squaring the error, that far away outlier has a disproportionate effect on the regression, right? Because all these will, if you just draw for a typical best fit line, if you draw a best fit line that passes through non-outliers data, the outlier data will have a huge error, and squaring that will have an even bigger error. So you sort of pull the whole regression line up to minimize that large error. Right? On the other hand, if you use absolute value of the error and then minimize the sum of that or the mean of that, it sort of penalizes these large errors much less than e square or mean square error, right? So because it penalizes the large errors much less, it can potentially sort of naturally less be affected by outliers, right? This is related to the fact that median is a good idea if you want to be robust against outliers. So we'll talk about that in a bit. It turns out this idea of using L1 regression is very closely related to using medians instead of means, okay? So let me stop there for this particular video, and then we'll talk about norms in the next video.